So nice. Yeah, we almost got it, Evan. Nice job. All right. What's up? All right, here we go. So this Delta Math link is called Analyzing First Derivative Algebraically. So you're going to see we're going to do a lot of algebra. We're going to use that information to make decisions and conclusions about the original function. Here's the first one. We're going to find all of the intervals on which f of x is increasing. I'm going to try my best, David, at the end to kind of link it all. I know you like seeing the Desmos graph. You can see how all this works, okay? So we're going to figure out what this graph looks like, all right, without actually graphing it, all right, which I thought was like the coolest thing when I was in high school, all right? Because yes, some of you are thinking, well, why don't you just graph it? Totally fair, right? But hey, what if you just can't? So first thing I want to do is find critical points. We talked about this last week. Do you guys remember how to find critical points? Yes. Yes, I heard a yes. Take the derivative. Oh, that's a highlighter. Take the derivative, and it's whatever makes this equal to 0. Now, just a quick little aside. Technically, a critical point could also make the derivative undefined. That hasn't happened yet. It won't happen today. But at some point, I'm going to show you that a critical point can also make the derivative undefined. Okay? So that will be happening at some point, not today. So let's take the derivative. I'll show all my work here. All right, ready? Okay. What is the derivative of negative 2x cubed? Excellent. Okay. What's the derivative of negative 27x squared?
54.
Negative 54x. Okay. And then for the next one, minus 84. Do I need to write plus 0? I do not, right? So this is the derivative. To find the critical points, I'm going to set this equal to 0. So now it becomes, we're going to take a pause on the calculus and switch into algebra mode. All right, so this is something you would have done in Algebra 2. All right, now when you look at these three terms, do they have something in common that you can factor out? 6. And also, I just says like, I think it's a good rule of thumb to make it easier on yourself to factor later. If there's a negative, take that out with it. If there's a negative in front of the squared term. So take out the negative 6. So you have x squared. What's negative 54x divided by negative 6? Plus 9x. And then does anyone know 84 divided by 6?
14.
Is 14. All right. Do you guys remember how to find these factors? Hopefully you do. What are factors of 14 that add to 7? 7. Did I say 7? I'm sorry, to add to 9. My bad. Factors of 14 that add to 9. My brain's already thinking about the answer. Everyone okay? Okay. Now, I mentioned this before, all right, last week. Is there an x with this negative 6 out front? No. So I'm not going to erase it, but do I care about it right now? No. I only care about the stuff that's going to make it 0. So what's going to make each of these 0? All right. These are called critical points. I need to like make a song. Okay. Now, wherever you've got room, I'm going to go to the side here. But if you've got room underneath, wherever, just keep going. All right. There's many different ways to organize this. I like to use a number line. Okay. So I'm going to draw just kind of a mini number line. And I'm going to put my critical points. What were my critical points? Negative 7 and negative 2. Okay? So essentially what I'm saying is that if I were to look at the original function at negative 7 and a negative 2, there's the chance that something interesting is happening. Okay? There's the potential for something interesting to be happening at negative 7 and negative 2. So what I'm going to do is I'm going to choose some points that are around that to see if that will help me determine what is happening. Okay? So I call these test points or TPs. No, not toilet paper. Test points. Okay? So if I had to choose a test point that's to the left of negative 7, what am I going to choose? I'm going to choose -8. Okay? But now every time you use toilet paper, you're going to be like, oh, test point. If I'm going to choose a test point between, can I get some more test points? -7 and not even a chuckle. Wow. Good Lord. This is forever, guys. Meanest students ever. Between -7 and -2, what am I going to choose? I always choose like the one that's just to the left of my farthest right number, but is -5 okay? Yes. Is -6 okay? Yes. -4 totally fine. Your choice. Okay? And I think hopefully we'll land on this one here. That's to the right of -2. So that's a good one to choose. If I can choose 0, I'm choosing 0. 0 is always, in my mind, easiest to plug in. Okay? You guys ready? Okay, so the next thing I write down is the sign of the derivative. I know, this is amazing. Gosh, we're having so much fun. Okay, let's see if I can zoom in for you. Do you see this right here? Fully factored before we solved. Okay, do you see my test points, my TPs? Separately, I'm going to plug those test points into my x's, and I'm going to write down what the sign of my derivative would be. Okay, ready? So I don't care what the number is. I just care if it's positive or negative. That's it. So what's a -8 plus 7 is going to be what? It's going to be a negative, right? I don't care what the number is. It's just going to be a negative. Okay? What's -8 plus 2? I don't care. You can stop saying the number. Just the sign. Just a negative. Okay? So what's a negative times a negative times a negative? It's a negative. You're good. No worries. Negative times a negative is a positive. Julia, you're okay. We all know you got it. No worries. Did everybody see what I just did? Do it again. But this time you're doing -3. What's -3 plus 7? Positive. What's -3 plus 2? Negative. So here we go. A negative times a positive times a negative. Just count how many negatives there are. If it's an even number, then it's going to be positive. Right? There's 2 of them. That's an even number. So this is a positive. That's how you do that. What, David? Yes? Okay. Plug in 0. Girls, you okay? Okay. Plug in 0. 0 plus 7, positive. 0 plus 2, that's a positive. So what's a negative times a positive times a positive? A negative. Now, here's the exciting part. Okay? If I tell you that between -infinity and -7, the sign of the derivative is negative, that tells me that on that same interval, the original function is decreasing. All right? Because all the slopes of the tangent lines are going to be negative on this entire interval. And I know I didn't write it, but your brain should be thinking, right, this is really -infinity, and this is really positive infinity. Yeah, you're doing so. I'm going to show you the graph, David, I promise. Okay? So here's what I put for my conclusion. Okay? Well, because it asked me in the problem, on what intervals is the original function increasing? So to answer this question, using the work we just did, I'm going to say, okay, students, where is my derivative? Where are the signs of that? Positive. Because if I find where the signs of my derivative are positive, that's where the original function is increasing. All right? So out of those 3 test points, did I get any that were positive? Yes. This one here. All right? And that's in between which numbers? -7 and -2. So the answer here is -7 to -2. That's it. This is what you're typing in to get full credit. David, go ahead.
So that means that throughout any point to -7 and -2, it's always increasing.
Always increasing. You're right. I'm going to show you here in a moment. Now, can we do a quick aside? I know it didn't ask this, but can we do a quick aside? Then where would it be decreasing? So it's going to be -infinity to -7. No, it's always the critical points, Jimena. So when you do the answer part, Jimena, use the critical points. The test points help you figure this out. But then once I use the test points, I don't care about them anymore. Right? I go back to my original critical points. So see how it was negative here? Yeah. And then where else was it negative? So okay, go ahead. Andre.
No, I'm just saying that.
Oh, I get it.
I'm using the critical points, yes, to write my answers. I can get a little confusing about what numbers. Kyle, go ahead. Yes, both of them, correct. Can we graph it now?
Why is it correct? Oh.
Those are intervals. So like when you did this, hopefully in pre-cal last year, when you asked where a function was increasing or decreasing, you should always use parentheses. Because you're saying over these x values. I'm going to show you right now, okay? All right, let's see. Was it negative 2x cubed?
Minus 27x squared minus 84x plus 24.
Okay. Now I'm going to type into this table my critical points as well as my TPs, my test points. So I believe it was negative 8 was a test point.
Yes.
Negative 7 was a critical point. Negative 3, negative 2, and 0.
Yes.
Are you ready? This is exciting. Are you guys ready?
Yes.
Oh my gosh, I'm so excited just to hit this little magnifying glass. Oh my gosh, I'm so excited. There it is. Okay. So we said our answer was that the function is increasing from negative 7 to negative 2. Negative 7 to negative 2, it's increasing. Okay, we said the function is decreasing from negative infinity to negative 7. So negative infinity, see how it's decreasing? To negative 7. All right, we also said it's decreasing from negative 2, right? Negative 2 to infinity. Isn't that cool? We can do all that without actually graphing it? Oh man, I thought that was the coolest thing.
I thought we were gonna have technology now.
Not yet, no, it's coming. Yes, we do have technology now. We did when I was in high school, but thanks for calling me old. No worries. Okay. Any questions? That was Valeria, by the way, for posterity. You have some questions? Oh no, you're just trying to share water. I wouldn't do that. Okay. Any questions on 1? If you can do number 1, then all the other questions are just variations on this. Okay, so I want you to think like you can do this. All right, can we do it in the next one? I'm probably going to stop after the next one so you guys can try. Yes, Edwin. Whenever it says increasing or decreasing, your answer should involve the critical points and potentially infinity or negative infinity. Yes. If it's not a critical point, I shouldn't see it in my answer. You're welcome. All right, let's try this one. This one is going to be the same process, but I'm asking for a different thing, a relative minima. Another word here is local extrema or local minimum value, okay? The process is identical, so let's find the derivative. Okay, ready? What's the derivative of 3/4 x to the 4th power? Say it one more time, Alan. I like the x cubed part, but how'd you get the 4 part? Did you multiply it by the 3/4? So if you do 4 times 3 is 12, divided by 4 would give you a 3 here, not a 4. Okay? That's just math. And then what's 14 times 3? Ooh, 14 times 3? 42 x squared plus 120x, and then derivative of 39 is 0. So this is the derivative. Now again, I want to say this every time so that people watching at home that I'm not going to put mean comments on my video. Technically, a critical point could make this become 0 or undefined. Now you'll notice this is a cubic polynomial. Cannot make it undefined. It's defined everywhere. So that's why I'm not doing that. I'm only focusing on where it is equal to 0. Okay, can we factor out anything from all 3 of those terms? 3x, nice. Okay, let's see what's left. X squared plus 14x, 120 divided by 3, 40. You okay, David?
Yeah.
Okay. And then I need factors of 40 that add to 14. Excellent. Now, ooh, interesting. It's my favorite part. Not really. Because if everything's my favorite, then nothing's my favorite. Oh.
You say everything's your favorite part.
You'll notice on this one, the 3 has what with it? It has the x with it. So do I care about this? I do. So what are my critical points? 0. Nice. So these are critical points. So the moment I write these, I don't know which one is the answer or if multiple are the answer, but my answer is going to be from those numbers. Okay? Because it's asking for where is a relative minima happening. At some x value, whether it's 1 or multiple, or all of them, there's going to be a relative minima. Okay? So I'm going to make the number line. I know. -10, -4, and 0. Ready for the test points? Okay, so what am I going to use for the first one? What's just to the left of -10? -11. What's in between -10 and -4? I'm going to do -5, -6, -7, -8, -9 are also fine. Okay. What's in between 0 and -4? -1. You can do -2, -3 if you want. And then the first thing to the right of 0 is a +1. Essentially, yes. I need to find a test point that's on both sides, right? So you'll notice that however many critical points you have, you're going to have +1 when it comes to TPs. Okay? Go ahead. Yeah?
For the first one, why'd you put 0?
The first one, why'd I put 0?
No, like...
Of my critical point?
Yeah, the first problem we did.
Great question. So in my first problem, the -6 that was factored out did not have an x with it. So that's why I didn't have 0. But this one, this 3 that I factor out does.
No.
Nope. Okay, just kidding.
In the timeline.
Oh, the TPs? The timeline. The number line? I got you. Why did I have 0 here and not here? If 0 is one of my critical points, it can't be a test point.
Yeah, but why did you choose 0? Because you said it's the first thing to the right.
So if there's like, for me, an exception to that rule. If 0 is a choice, I always choose 0. You're saying, like, why didn't I choose -1? Totally fine. Choose -1. I think it's just easier for me to plug in 0. Great question. All right. Ready? Let's do -11. You guys want to try this mentally? No? Okay. All right. So what's -11 plus 4? A negative, right? A negative. What's -11 plus 10? Negative. So that's -11 times 3 is a negative. So that's how many negatives? An odd number. So the sign is going to be negative. I erased way too much. There we go. Okay. Do the next one. -5. -5 plus 4 is a negative. This will be a negative. -5 plus 10? Positive. So how many negatives? That's an even number, so this will be positive. Now, I just want to wait till I finish before I say it. Okay, wait till you finish. Let's come on. Okay, the last one. Just get so excited. So I want to make sure if it doesn't happen on this, I want to mention it. -1. This is a negative. -1 plus 4. Positive. -1 plus 10. Positive. So that's going to be a negative. And the last one is a +1, which everything's positive, right? Okay. Oop, I erased a 3. Sorry about that. Now, I want to say this because I know you guys think that's going to happen every time. We're not going to do numbers 3 and 4, but one of them, this happens. You see how so far they've kind of switched every time? Same thing here. I just want to tell you right now, and you don't believe me until I do it, right? That's not always going to be true. There might be a time where you go negative, negative, or positive, positive, back to back. So just be careful. Don't just be like, oh, the first one's negative, then I'm just going to do alternate on all the next ones. Don't do that. All right, you'll get something wrong. Okay? Everybody go? Do you see what I'm saying? All right, it's not always just going to be this pattern where they alternate. Sometimes it might be negative, negative, positive, positive, right? Who knows? You got to do it. Got to do the TPs. So far, Georgie, let me zoom out. See how like whatever the first one was, we've just alternated? It won't always be like that. Like sometimes you might double up like, oh, 2 negatives in a row or 2 positives in a row. It just means that when you do the next test point, it'll be the same sign. Oh, great question. I'm not going to answer that right now, but it's going to happen. Okay, are you guys ready to answer the question? Because this does not say where does the function increase or where does the original function decrease? Because if we did, our answer would be an interval. Okay, so what I do is I go to the problem. It says minima, and I do this. I did this when I was taking the AP exam. When I do a minima, right? Minima means I am decreasing, switching to increasing. If I go from decreasing, switching to increasing, what happens right there? That's my relative minima or minimum value, right? Decreasing to increasing. So when I look at my number line with my signs, SIG and S, I'm looking where I'm going from negative to positive. Negative to positive. All right? So negative to positive. So one of my critical points here, what's my critical point here? That I have a relative minima. Negative 10. Negative to positive. Is that happening at another place? Yes. Negative to positive is which critical point? 0. So at x equals negative 10 and x equals 0, I'm expecting to see a relative or local minima. You ready? I'm almost done, and that's going to be your time to shine. I didn't mean like shine by going to the bathroom. I meant like trying some problems. Okay. Somebody give me the problem? No? No one cares? Can you just read the problem for me? Yeah, Julia? No, oh, Julia said no one cares. Oh, Julia. 3/4. So, Guy, just asked, but I'm going to get you. What is it?
Plus 14x cubed.
Thank you. Was that 60x squared? And then plus 39? Okay. All right, let's do all our stuff. There's a lot here. What was it? Negative 11? Negative 10? Negative 5 and negative 4? And then 0 and 1? Okay. You guys ready? Okay. All right, we said that we have local or relative minima at x equals negative 10. Take a look here. Do you see x equals negative 10? We call that a relative minimum. Okay? And then we also said 0, right? Right here. See how the function is decreasing to then increasing? So that is another relative or local minima. Who's got questions?